for personal computers during the mid-1990s. The original design was re-implemented in newer processors and new features were added to maintain its competitiveness, and to address specific markets such as portable computers. As a result, there were several variants of the P5 Microarchitecture. P5. The first Pentium microprocessor core was codenamed P5. Its product code was 80501. 80500 for the earliest steppings Q0399. There were two versions specified to operate at 60 MHz and 66 MHz respectively, using socket 4. This first implementation of the Pentium used a traditional 5-volt power supply, descended from the usual transistor logic, TTL, compatibility requirements. It contained 3.1 million transistors and measured 16.7 mm by 17.6 mm for Intel Pentium microarchitecture in an area of 293.92 mm 2.20. It was fabricated in a 0.8 micrometer bipolar complementary metal oxide semiconductor, BiCMOS, process. 21. The 5-volt design resulted in relatively high energy consumption for its operating frequency when compared to the directly following models. P54C. Intel Pentium P54C die shot. The 5P was followed by the P54C 80502 in 1994, with versions specified to operate at 75, 90, or 100 MHz using a 3.3 volt power supply, marking the switch to socket 5. This was the first Pentium processor to operate at 3.3 volts, reducing energy consumption, but necessitating voltage regulation on mainboards. As with higher clocked 486 processors, an internal clock multiplier was employed from here on to let the internal circuitry work at a higher frequency than the external address and data buses, as it is more complicated and cumbersome to increase the external frequency, due to physical constraints. It also allowed two-way multiprocessing, and had an integrated local APIC and new power management features. It contained 3.3 million transistors and measured 163 mm 2.22. It was fabricated in a BiCMOS process which has been described as both 0.5 man 0.6 micrometer due to differing definitions. 22. P54CQS. The P54C was followed by the P54CQS in early 1995. Which operated at 120 MHz. It was fabricated in a 0.35 MBCMOS process and was the first commercial microprocessor to be fabricated in a 0.35 micrometer process. 22. Its transistor count is identical to the P54C and, despite the newer process, it had an identical die area as well. The chip was connected to the package using wire bonding, which only allows connections along the edges of the chip. A smaller chip would have required a redesign of the package, as there is a limit on the length of the wires and the edges of the chip would be further away from the pads on the package. The solution was to keep the chip the same size, retain the existing pad ring, and only reduce the size of the Pentium's logic circuitry to enable it to achieve higher clock frequencies. 22. P54CS. The P54CQS was quickly followed by the P54CS, which operated at 133, 150, 166 and 200 MHz, and introduced socket 7. It contained 3.3 million transistors measured 90 mm 2 and was fabricated in a 0.35 micrometer BiCMOS process with 4 levels of interconnect. P24T. The P24T Pentium overdrive for 486 systems were released in 1995, which were based on 3.3 version 0.6M versions using a 63 or 83 MHz clock. Since these used socket 2/3, some modifications had to be made to compensate for the 32-bit data bus and slower onboard L2 cache of 486 motherboards. They were therefore equipped with a 32 KB L1 cache, double that of pre-P55C Pentium CPUs. P55C. Intel Pentium's microarchitecture Pentium MMX 166Ms without cover the P55C, or 80503, was developed by Intel's Research and Development Center in Haifa, Israel. It was sold as Pentium with MMX technology, usually just called Pentium MMX. Although it was based on the 5P core, it featured a new set of 57 MMX instructions intended to improve performance on multimedia tasks, such as encoding and decoding digital media data. The Pentium MMX line was introduced on the 22nd of October, 1996, and released in January 1997. 23. The new instructions worked on new data types. 64-bit packed vectors of either 8 8-bit integers, 4 16-bit integers, 2 32-byte integers, or 1 64-bit integer. So, for example, the PAD-USB, packed add unsigned saturated byte, instruction adds 2 vectors, each containing 8 8-bit unsigned integers together, element-wise, each addition that would overflow saturates, yielding 255. The maximal unsigned value that can be represented in a byte. These rather specialized instructions generally require special coding by the programmer for them to be used. Other changes to the core include a 6-stage pipeline, versus 5 on 5P, with a return stack, first done on Cyrix 6x86, and better parallelism and improved instruction decoder. 16 KB L1 data cache plus 16 KB L1 instruction cache with both 4-way associativity, versus 8 KB L1 data forward/instruction with 2-way on 5P, 4 write buffers that could now be used by either pipeline, versus 1 corresponding to each pipeline 5P, and an improved branch predictor taken from the Pentium Pro 24/25. With a 512 entry buffer, versus 256 on 5P. 26. It contained 4.5 million transistors and had an area of 140 mm2. It was fabricated in a 0.28 micrometer CMOS process with the same metal pitches as the previous 0.35 micrometer by CMOS process. So Intel described it as 0.35 micrometer because of its similar transistor density. 27. The process has 4 levels of interconnect. 27. While the P55C remained compatible with socket 7, the voltage requirements for powering the chip differ from the standard socket 7 specifications. Most motherboards manufactured for socket 7 before the establishment of the P55C standard are not compliant with the dual voltage rail required for proper operation of this CPU. 2.8 volt core voltage, 3.3 volt input forward/output, I forward/O, voltage. Intel addressed the issue with overdrive upgrade kits that featured an interposer with its own voltage regulation. Tillamook. Pentium MMX notebook CPUs used a mobile module that held the CPU. This module was a printed circuit board, PCB, with the CPU directly attached to it in a smaller form factor. The module snapped to the notebook motherboard, and typically a heat spreader was installed and made contact with the module. However, with the 0.25 micrometer Tillamook mobile Pentium MMX, named after a city in Oregon, the module also held the 430TX chipset along with the system's 512 KB static random access memory, SRAM, cache memory. Models and variants. Pentium and Pentium with MMX technology KL Intel Pentium P5.jpg. Pentium 60SX948 Gold Front.jpg. KL Intel Pentium 75.jpg. Pentium Front.jpg. Pentium TT80502-75SK089 Observe.png. Intel Pentium 133.jpg. KL Intel Pentium P54C200.jpg. IC Photo Intel TT80502-133-PP133 Mobile Pentium CPU.jpg. KL Intel Pentium MMX.jpg. Intel Pentium MMX 166 PGA Front.jpg. Codename P5 P5 4C QSB54C SB55C Product Code 8050180502805003 Processes M 0.800.60 or 0.35 0.350.35 later 0.28 die area millimeter 293.92 16.7 x 17.6 mm 148 at 06 m/91 later 83 at 0.35 m91 later 83 141 at 0.35 m/128 at 0.28 number of transistors millions 3.103.203.304.50 socket 4 socket 5/7 socket 7 package CPGA/CPGA plus ISCGA/CPGA plus IHS/TCP *CPGA/TCP *CPGA/TCP *CPGA/CPGA/P clock speed megahertz 60665010120 bus speed megahertz 6065060566066606660666066 core voltage 5.0 5.153.329 3.32.9 3.33.1 2.9 3.33.1 2.9 3.33.1 2.9 3.33.1 2.9 3.33.32.2 2.4.
Yes, a lot of numbers. Let's read from here.
Embedded versions of Pentium with MMX technology KL Intel Pentium MMX embedded top.jpg. KL Intel Embedded Pentium MMX PGA Bottom.jpg. Codename P55 Ktalamuk Product Code FV8050366200 FV8050366233 FV8050 CSM66166 GC8050 CSM66166 GC8050 CS166 XTV8050 size M 0.350.25 clock speed megahertz 20023166166166266 bus speed megahertz 6666666666666 package PPGA TDP maximum W 15.7174.54.14.17.67.6 voltage 2.82.81.91.81.81.92.0 Competitors After the introduction of the Pentium, competitors such as Next Gen, 28, AMD, Cyrix, and Texas Instruments announced Pentium-compatible processors in 1994. 29. CIO magazine identified Next Gen's NX586 as the first Pentium-compatible CPU. 30. While PC Magazine described the Cyrix 6X86 as the first. These were followed by the AMD K5, which was delayed due to design difficulties. AMD later bought Next Gen to help design the AMD K6, and Cyrix was bought by National Semiconductor. 31. Later processors from AMD and Intel retain compatibility with the original Pentium. See also. List of Intel CPU microarchitectures. List of Intel Pentium processors. Cache on a stick, Coast, L2 cache modules for Pentium. IA32 instruction set architecture, ISA. Intel 82497 cache controller. Competitors. AMD K5, AMD K6. Cyrix 6X86. Winchip C6. Next Gen NX586. Rise MP6. References. 1 product change notification #7.
Good. That was last edit a few days ago, 13 August. So I didn't read this Pentium, but we should maybe try to continue the Pentium Pro. We could do that tonight, but I need a few minutes. I think I'm start to upload this, and I have to download a fresh copy of the Pentium Pro. So I will start upload this and charge the camcorder a little bit. So let's do that.